Right, good morning, everybody. Welcome to this webinar on applying PAS 2038 to traditional and historic buildings. I'm John Edwards and I'm chair of the IHBC Technical Panel, and I'm going to be delivering this webinar this morning. Just a little bit about myself. I've been the Technical Panel chair for a few years now. I've been an IHBC member for longer than I care to remember. It's a long time, a couple of decades. And I've been very much involved with retrofitting buildings since the 1980s, including building fabric and building services, and including domestic and non-domestic buildings, including Grade 1 listed buildings. So I've been at this a long time. When I originally first started doing this, it wasn't about saving the planet, it was about saving money. And in those days, we didn't even call it retrofit. Anyway, this is a number of webinars that the IHBC Technical Panel have been developing and will deliver into the future. And it's also a build-up to the IHBC Annual School taking place in Reading in June. Anyway, let's make a start on the content. So what I'm going to be doing is giving you an overview, basically, what this subject is about. It is basically about the retrofitting of non-domestic buildings. Okay, non-domestic buildings which are special protection, traditional and historic. I can only give you an overview because it's such a big subject, and I will be taking you through the stages of what PAS 2038 is, rather than a lot of the technical data that's normally involved in the retrofitting of buildings. So BSI have published PAS 2038 in 2021. I've been a member of the panels that have been producing those PASs, those BSI standards on retrofit, which includes PAS 2038. I also took the lead in the development of BS 7913, which is a key part of the application of PAS 2038. But let's look at some of the objectives and some of the principles involved that BSI actually comply with or try and adhere to when they're developing standards. And these are very fine objectives, they're very fine principles. So the first one is improving functionality and durability of buildings. I think that's a very fine one because that is about sustainability. And when we are retrofitting buildings, we must have sustainability firmly on our mind to make sure we're certainly not making buildings worse, but that we are going to be able to sustain buildings going forward into the future. Improving the comfort and well-being of occupants. And the next two very much related to each other, and some people will say this is the core part of what this is all about. Improving energy efficiency, reducing the environmental impact, and the latter is particularly important. Protect, not just protect, but enhance architectural heritage and minimize that performance gap. The gap between the performance we think we're going to achieve when we execute all those measures recommended by an energy model, and then when we've installed those measures, we don't quite achieve those energy efficiency performance targets, and that is known as that performance gap. And also avoiding those things that go wrong, the unintended consequences, and of course adopting these principles as well. Now, if you're not involved in the development of standards, and most people aren't, I think when you are developing a project, I think you need to look at these objectives and see and check your scheme, see that it is complying with these particular objectives. And even if you're judging other people's schemes, that's exactly what you should be doing. Anyway, this is the BSI Retrofit Standards Framework. I'm not going to talk about the boxes at the top, but let's focus on the boxes in the middle. And the two core parts of the BSI Retrofit Standards Framework is PAS 2035 for dwellings and PAS 2038 for non-domestic buildings. And you can also see from the boxes at the bottom, we have non-BSI standards, new BSI standards, and existing BSI standards. And existing BSI standards includes PAS 2030, BS 5250, which is the British standard for managing moisture, and BS 7913, the British standard for dealing with older, traditional and historic buildings. But not all of these boxes at the bottom, or these standards highlighted in the boxes at the bottom, will be part of this framework in their totality. For example, it's only certain parts of BS 7913 are part of this framework, wherever either PAS 2035 or PAS 2038 directs you to those particular parts of those particular documents. So let's look at these BSI standards as far as retrofit is concerned. So for homes, we have PAS 2035. PAS 2035 is basically a process that's a retrofit process, purely and simply retrofit, and it got some elements of standards, some elements of principles, and some elements of competency and qualification requirements, but it's largely a process, a retrofit process, but it does indicate the buildings should be in good condition before you retrofit them. Now, the installation side of that particular process refers you to PAS 2030. PAS 2030 looks like a completely different document. Apart from the few pages at the beginning, it's got dozens of annexes or appendices, and each of those appendices refers to a specific retrofit measure. So it's got a lot of detailed information about those particular measures. PAS 2038 is the equivalent to PAS 2035 in every single way. It doesn't look the same. It's not the same standard. In fact, I think it's a better document, but it does the same. It's largely a process. And the implementation side of PAS 2038, as far as the installation of the measures are concerned, is again PAS 2030. Why bother reinventing the wheel? But because there are additional measures that you could install into a non-domestic building compared to a domestic one, PAS 2038 has also got an Annex A, which details additional retrofit measures. So both these particular standards are referred to in PAS 2038. We've got the European standard BSCN 16883, basically the European standard for retrofitting historic buildings, and we've also got BS 7913, and BS 7913 is also referred to by PAS 2035. The European standard isn't. So when we are adopting PAS 2038, we also have to comply with PAS 2030. So you need to refer to that particular document. And you also need to refer to these other two documents as well. Indeed, if we look at section 5.4 of PAS 2038, it says traditionally constructed or protected buildings, if the building to be retrofitted is of traditional construction or protected, an assessment of its significance should be carried out in accordance with BS 7913. B, an assessment of the building should be carried out in accordance with BS EN 16883. So let's see what PAS 2038 actually covers. I'm not going to read the words on each and every single slide I show you. We'd be here over an hour, well over an hour if I did that. It might get a bit monotonous. So they're here for you to read. But if you can look at what it covers some very sensible things. And if you are familiar with PAS 2035, and many people have a greater familiarity with that particular document, you'll see it covers more or less the same things. There's a few things that are different, like there's fine-tuning in PAS 2038. You don't see much of that in PAS 2035, but that's basically what the document covers. And let's look at a very brief summary of this document. And this document's been developed for all different kinds of non-domestic buildings of all types and all ages, from a building like the Shard in central London to, I don't know, a castle, everything. Like I said before, it's largely a process with standards. I mentioned that it doesn't contain any risk paths because the 2019 version of PAS 2035 does contain risk paths. This doesn't. This has been set up on the basis that there will be a professional team executing the retrofit process. That is not the way in which PAS 2035 has been set up. In fact, there's just a handful of people involved in any retrofit of a dwelling, in accordance with PAS 2035, whereby there'll be a professional team where PAS 2038 is concerned. But the size of that team depends on the size of the project. We can use PAS 2035 for domestic-like buildings. It doesn't mention fabric first. It doesn't mention fabric first at all. PAS 2035 does mention fabric first, but it also details that where traditionally constructed buildings are concerned, a risk-based approach is normally more appropriate. And where PAS 2035 is concerned, it does indicate that you should carry out fabric first all the time, except for traditional buildings. But then it goes on and says you've got to put the building into good repair. You need to do the low-hanging fruit. You need to replace any distressed heating installations and distressed boilers, and then it's fabric first. I should also point out that other documents produced by the likes of the UK Green Building Council also indicate that we shouldn't necessarily be taking a fabric first approach all of the time. Let's make that one loud and clear. So like I said, it details competencies and professional memberships, but unlike PAS 2035, it's not written in a very strict way, because it does mention certain professional memberships, but it accepts that there could be equivalents to that, and that should be okay. I've already mentioned PAS 2030 is part of this picture as well. There is an evaluation. For buildings of over 1,000 square meters, I know there's not a lot of them, about 7%, I believe, of UK non-domestic buildings are over 1,000 square meters, but for those particular buildings, there are additional requirements as well. And very importantly, older buildings are differentiated. Though this is an illustration I've taken from PAS 2038, and it indicates the range of different uses that non-domestic buildings will receive. And by looking at this range of different uses, you can imagine the huge variety of non-domestic buildings that exist within the UK. Now, in the UK, people use different figures all the time, but they reckon there's about 27-point-something million dwellings or buildings, and there's 2 million non-domestic buildings. So non-domestic buildings, a lot fewer in number, but if you can imagine their size and complexity, they're still part of the major picture in how we're going to be dealing with climate change. So let's accept that, and let's move on and have a look at the overall process. So very briefly, if you look at the red arrow, you can see that that is the overall process for all buildings. And then the red arrow is moving to tell you that where we have domestic-like non-domestic buildings, we can follow PAS 2035 instead. Where we have traditional and protected buildings, and note that they're clubbed together, there are some additional requirements there, as you can see. And when we have buildings over 1,000 square meters, further additional requirements. And in the option column, it's indicating there we've got some choices to make in terms of the way we're going to be adopting and progressing this retrofit project. So let's focus on the main process. Now, I am going to take you through the main process as well as I can in the time I've got, but I'm going to try and put that into context in terms of its application to traditional and historic buildings, protected buildings. So the first stage is appointment of the project team and the retrofit lead professional, agree the brief, and agree what we're going to be doing, basically. If you're used to PAS 2035, the equivalent person would be a retrofit coordinator, but here it's a member of the leading member of the project team. So the retrofit lead professional will be applicable to all projects. If it's a very small project, there may just be one member of that team, a professional team, and that would be the retrofit lead professional. But very often there could be lots of people in that team, and that retrofit lead professional will lead, and all projects will have such a person. That person can be employed as a client, could be employed by an in-house member of staff. It could be somebody who's actually undertaking other roles as well, or it could be somebody who's been appointed to specifically take on that particular role. And where we get that person from in respect of the professional expertise that person has depends on what shape the project is. Is the project primarily building services and equipment, or is it primarily building fabric? And if it's primarily building fabric, then that person should come from a building fabric background. If it's not, then it could come from a building services background. And that's the way that this PAS 2038 has been set up. But when you look at right, I'll go into the range of roles, the range of the responsibilities that the retrofit lead professional has in a moment. But The Retrofit lead professional shall inspect the building with the client or the client's representative and review the overall objectives of the project. What is the project meant to achieve? It will also reviewing what is the intended outcome. What is the outcome required? Looking at all the various different types of constraints, costs and budgets, and also looking at the retrofit process and the requirements that PAS 2038 places on such a project. Now we come on to the range of responsibilities that the retrofit lead professional has. I'm not going to read out all the words here, but you can see it's a broad range of areas that the retrofit lead professional has to take on board. You're negotiating with people, you're doing your contract administration, you're doing your defect inspections, you are bringing a project overall to a satisfactory conclusion. You have a wide range of responsibilities, and I would say that is a very challenging role for a lead professional to undertake. If we look at the project team members, the size of the project team will depend on the size of the project and its complexity. And as you can see there, detailed in number 2, project team members will be qualified. And you can see a range of those qualifications which are detailed there. And like I said, this is written in a flexible way. Compare that to PAS 2035, which is very much written in a dogmatic way. This is flexible in terms of the professional memberships and other qualifications, which are detailed here. But project team members have to be qualified. At least one member of the project team shall be competent to undertake these particular activities. So, PAS 2038 is living in the real world. There will not necessarily be qualifications for all these different types of activities that need to be undertaken. But what PAS 2038 is saying, that people undertaking these activities shall be competent, sufficiently competent to undertake them properly. At least one member of the project team shall hold a qualification for these activities. So there needs to be at least one person in the project team who has a qualification and is sufficiently qualified to undertake these activities. I'm not saying all members of the project team, but at least one member of the project team. Now we go on to the next stage of PAS 2038, which is the assessment. The assessment, and that assessment is wide-ranging. Now, number 1. When there is more than one assessor, and I would imagine in most retrofit projects involving non-domestic buildings, there'll be different types of assessors, and each of those assessors must be competent to assess those things which have to be assessed. And therefore, there will be a lead assessor. There should be an assessment for improvement. And this isn't just in terms of energy efficiency improvement, it covers a range of activities. And bearing in mind, when we're looking at retrofitting to do with climate change, it isn't just about making buildings more efficient, it's also making sure that buildings can actually be more resilient to the effects of climate change. So we need to assess everything that will be improved. We need to also assess and take on, well, before we go on to that, let's look at one area of assessment. Again, I'm concentrating on issues concerning traditional and historic buildings. So one thing that has to be assessed is the context. And as you can see here from areas I've lifted from the document itself, the building's architectural, cultural, and historic context and its physical setting, including aspect and exposure, access, planning constraints, etc. Those are things that have to be assessed. But if you note here, there are other things to be assessed as well, as detailed in this document. But we haven't got time to dwell on it at the moment. So we need to understand all those constraints of all different kinds. We also need to understand regulatory issues as well. And let's take a glance at some of the specific words within PAS 2038 in section 5.2. So it says the assessment shall include an appraisal of the building's heritage, architectural features, and so on and so forth. Identification of any constraints and regulatory requirements. And that means the listing of a building with special architectural or historic interest, location in a conservation area, tree preservation orders or archaeological investigations. So these also need to be assessed. We also need to assess and identify defects, moisture issues, and previous retrofit work that's been undertaken. And when we're identifying the previous retrofit work that's been undertaken, isn't just the fact that a particular measure has been installed. We need to understand that in detail. If it's insulation or walls, for example, what sort of materials is it? What are the construction details? We need to find all of that information out if we are to do a proper assessment. We've also got to do an occupancy assessment as well. You can see the range of issues that come under that occupancy assessment. And we also need to do measured surveys. But sometimes that measured survey may have already been undertaken, and you may have all that information from that activity that's already been completed, maybe sometime in the past. We need to understand the construction and thermal properties of the building. And we need to understand all these other things as well: existing building services, technologies, building services, control zones, fuel bills, manuals, passive measure potential, and all these things need to be assessed as far as that is concerned. And also any suggestions by the assessor, because the team of people undertaking this assessment should be truly competent people, because a lot rests on this particular part of the process, so it needs to be undertaken properly. If you've got competent people doing it, then they can also come up with suggestions of how we're going to improve this building. Now let's focus on something that is written into PAS 2038, but isn't described in this way. But I think everybody needs to understand this. Understanding the difference between traditional buildings and modern buildings is absolutely key. And when you're looking at this illustration here in front of you, we are showing an illustration of a section through a traditional building on the right-hand side and a modern building on the left-hand side. The traditional building typically comprising vapor-permeable building fabric, vapor-permeable enclosing walls, and solid floors. When it rains on the outside, moisture will ingress into the external surfaces of these enclosing walls. The moisture will soak in. And when the rain stops and the sun comes out, most of that moisture will evaporate by the external face of the enclosing walls. But some of it may evaporate internally in a very equal way, in a very minor way. We're talking about vapor, not liquid. We're talking about liquid in a gas state, evaporating through the internal surface of the enclosing walls and through the surface of the floors, like I said, in a very equal and minor way. And any moisture does accumulate within the interior of the traditional building will disperse into the atmosphere through natural ventilation, because we have open chimney flues, windows that don't quite fit, and the like. And that is the way traditional buildings have been performing for many hundreds, if not more years, until we start modernizing them, of course. And if we compare that with the modern construction of today, comprising to varying degrees building fabric which is vapor impermeable, and in many spaces, certainly within non-domestic buildings, requiring mechanical ventilation or other types of ventilation and air conditioning systems to remove moisture that does accumulate. But we can see that these buildings are different and they need to be treated differently. The unfortunate thing is that in the UK, we very often treat the traditional building as a modern building, and we do it all the time, whether it's a non-domestic building or a domestic building. And why is that the case? Is it because traditional buildings are a niche area? Well, it shouldn't be, because overall, I think we can say that, just under 25% of buildings in the UK are of traditional construction, but that's only by looking at that pre-1919 date, which is a bit of a misnomer, to be perfectly honest. And if we look at a definition of a traditional building in PAS 2038, and we marry that up with some data from the Buildings Research Establishment, we will see we're not talking about a quarter, but we're talking about a third. A third of buildings in the UK are of traditional construction. If we think back to the UK Department for Energy and Climate Change, which disappeared quite a long time ago now, it said on their website approximately 35% of dwellings in the UK are of traditional construction. Well, yes, we're not looking at dwellings today, but it is often noted that about a third of non-domestic buildings are of traditional construction. So there's a great many of them. We shouldn't be treating them as a niche. there are well, there's not millions of non-domestic buildings, but certainly there are millions of traditional buildings in the UK generally. Anyway, let's put some meat on the bones of the key differences of these two different building types, because this is something we really do need to understand. Because as a rule of thumb, around about 80% of all problems in buildings have something to do with moisture. So with traditional buildings, we are managing the moisture because moisture moves in, moisture moves out. I suppose a good word to use would be to say that the building fabric is vapor open, as opposed to modern construction where we're blocking the moisture and the building fabric is vapor closed. So let's understand that. And if you need to know anything else about dampness in buildings, and I do deliver a one-day course on that, if anybody's interested, then you go to that organisation or the IHBC to find out more information about that. I want to emphasise something that isn't always emphasised in these PAS documents, and that is the importance of this assessment. I believe the assessment is the foundation for everything else that follows. Maybe I'm overemphasizing it because in the world of retrofit, people will remind me that other people are also going to be doing an inspection, and that is the retrofit installers, the contractors. But I believe this should be done in a very robust way, as we would with any project with a professional team, the sort of projects I've been delivering for many decades. So the quality of the outcome of this assessment is of critical importance, and that is determined by the type of building survey, the type of assessment, the competency of the persons undertaking it, and also the equipment being used. And if there is any compromise made on any one of these three areas, then I would say the overall outcome is compromised. So let's remember that. It's not specifically stated in PAS 2038, but let's remember that anyway. So I'm very briefly galloping through all these particular issues. There's a lot more detail to be talked about, but we simply wouldn't have the time. So when we are reporting the assessment, this is recorded in a report. And if there are a number of similar buildings which are to be reported on, they can be included in a single report. And let's bear in mind the last point is that the Retrofit lead professional shall review the assessment report with the lead assessor. So that completes the assessment stage. Now I want to look at the evaluation of improvement options, and that is looking at the range of different things we can do in order to understand what targets we can achieve, and then working out how we can actually achieve those targets in the most appropriate way. So let's just summarize what it says in PAS 2038 about that particular stage. So at this particular stage, we're feeding in from the previous stages, in particular, the retrofit assessment, which includes any energy modelling. We need to consider all the options in order to determine the optimum range of measures that we are going to install into the building to achieve the targets we need to achieve. Now, when we look at all the different measures that can be installed, well, we're going to very, very briefly look at these measures because we are referring to PAS 2030. And as you can see in PAS 2030, each of these measures are detailed in detail in PAS 2030, and therefore PAS 2038 is referring us to the description of all these particular measures as you can see in PAS 2030. And of course, these are all fabric measures. But it's not just fabric measures, there's building services, technologies, equipment, also measures that we'll be focusing on as part of the options. We should be considering all these different range of options together. Remember, it's not fabric first, it'll be a risk-based approach that should be taken. And of course, there are some measures which are not included in PAS 2030, and these are the measures which are detailed in Annex A of PAS 2038. So these are other measures that will be considered. Now, this is something that is not detailed in PAS 2038. It is not, but it is contained in PAS 2030. It is contained in PAS 2035, and it's the measure interaction matrix. And if you look on the right-hand side of this slide, that is the matrix, and it details, or lists, I should say, the retrofit measures horizontally and diagonally. And where we end up on a box of a certain color, that means something. And I've copied and pasted and blown up a close-up of the measure interaction matrix on the left-hand side of the slide, and look at the key. So if you end up on a green box, the measures are independent and do not interact. If you end up on a yellow box, the measure interact or may connect and require construction details. If you end up on an orange box, you've got some thinking to do, because the measures interact and require complementary specification and/or upgrade. And what that means exactly depends on what measures we're talking about, that we're looking at, that may interact. And if we end up on a red box, then those things do not go together into the building. So I would say that you don't have to use this measure interaction matrix, but I would say when we're looking at measures that we possibly want to install into the building, and initially they would be the measures that would be deemed as by the retrofit, by the energy modeling, to indicate we can reach a certain rating if we actually, or a certain performance standard if we actually install those measures. Those measures may be the starting point, but we can initially assess those measures and other measures that we may want to consider by using this measure interaction matrix. And maybe we'll end up excluding some of them along the way as we use a tool like this. Like I said, we don't have to use it, but I think it's a good tool to use. And something else that's not in PAS 2038 is the STBA guidance wheel. I wouldn't say it's excellent, but it's very good. There's nothing excellent out there, is there really? But there's nothing better than this, I would suggest. So again, this will enable us to actually take us through to a whole building approach. The measures that we want to install, we'll actually put our cursor on those particular measures. We see other arrows spring out, and at the tips of all those other arrows, there are other things that we must also consider installing into the building. I'm not saying we necessarily will. That takes a lot of research. It takes a lot of delving into the detail, which is also found in this particular wheel. And then once we've decided to do some of these other things, these other measures, there'll be other arrows springing out from them, and it indicates these other things that we should be considering. So again, it's not in PAS 2038, but I would say it's a very good tool to use. We must also meet the client's brief, and some clients are more informed than others. And if we haven't got clients who are particularly well informed, then we've got to help them consider what other things should be included in the brief. And that could be a very wide range of issues. And there's some detail within PAS 2038 that indicates some of those things that should also be considered. We should take into account all the different types of constraints, from physical constraints to legal constraints to use constraints, all sorts of constraints. Everything needs to be technically sound. And let's bear in mind, something that's technically sound on a modern building may not be technically sound on an older building. So you've got to really be competent in dealing with older buildings if you are going to successfully implement the retrofit of non-domestic buildings, which are either of traditional construction or protected. And we also need to, it also covers all these other things as well, targets, recommendations from the retrofit assessor, financial paybacks, and of course there'll be a report produced that will inform the basis on what the plan of improvement will entail. So that's stage 3. And stage 4, agreement on the intended outcomes, including the targets. So what it covers generally, the retrofit lead professional provides clients with reports on the assessment and improvement option evaluation and agrees and records the intended outcomes. And number 2, the intended outcomes take into account condition, reduction in energy use and greenhouse gas emissions. And you can see what it states there in note 2. For all types of retrofit projects, supplementary intended outcomes should be expressed in terms of one or more of the following. So you can read what all those things are there, detailed in front of you. And some of them are quite obvious, aren't they? Quite obvious. Anyway, those other things that maybe a client should be considering, at least one of them, but it will include at least one of them for all retrofit projects. Then we got a number 5, preparation of the plan of improvement. And let's see what that covers. Well, it covers a wide range of things, doesn't it, really? And have a good look at it. Identifying all the improvements necessary for energy efficiency improvements, possibly up to 2050. But you may not be able to do that all at one time, so it might be in stages. It's prepared by the Retrofit lead professional and the project team. Details constraints, details existing performance, and that will be an estimate because that will be based on the energy efficiency assessment. Takes into account that any other plans the client may have, identifies repair and maintenance issues that are picked up by the assessor, the potential impact of climate change and how to mitigate them, the scope for improving energy efficiency, identifying ways of eliminating the use of fossil fuels, reducing greenhouse gas emissions, also focusing on health, culture, architecture, identifying the interactions between the measures, identifying the optimum order of retrofit installations. And remember that order will be influenced by the need to negate any risk about on abortive work being undertaken, and also negating any risk of unintended consequences between each particular stage in the implementation of the measures. And emphasising, of course, within the plan, the importance of maintenance and repair that secures energy efficiency and identifies constraints. That takes us up to number 14, but there's also a number 15, and that is a retrofit strategy that embraces approaches to and standards for rearranging space and reconfiguring building surfaces to save energy, insulating, air tightness, heat storage, daylighting, solar gain control, natural and mechanical ventilation, moisture risk management, heating, cooling, and hot water lighting and small power, and other services such as lifts, communications, etc., building services controls, metering, and monitoring. So as you can see, the range of improvements that we can make to the building can be very broad indeed, and it's this full range of issues that must be considered in a comprehensive retrofit project. And that was number 5. Number 6 is about design and specifying of the work. And briefly, what does that cover? So there will no doubt be more than one designer, I would say, in almost all retrofit projects involving non-domestic buildings. And one of those designers will be deemed to be the lead designer. The designer will be fed by all the other information that's been gathered to date. So the designer must be in possession of all the reports and all the information necessary for the designers to actually design. The designer will deal with moisture issues, and also the design will also put the building into good repair. And the design will be reviewed for its suitability by the Retrofit lead professional. I keep on thinking that Retrofit lead professional has an awful lot of responsibility to take on board. And of course, the design should be based upon the specifics of each of those measures, which are detailed both in PAS 2030 and Annex A of PAS 2038. And then we reach the stage of getting consent for work. I don't need to go into detail about all that. That will be the subject of another webinar, I suggest. That will be very detailed where protected buildings are concerned. Site implementation. And where site implementation is concerned, again, we'll be complying with the detail of each measure that's described in Annex A of PAS 2038 and also PAS 2030, because there is a lot of detail in respects of each of these measures in those particular documents. So we need to comply with that at the site implementation stage. So we need to comply with the detail in those documents, but noting the responsibilities placed upon the installers. So there's a great emphasis in all these PAS documents about the responsibilities of the installers, to some extent, almost like a design and build sort of concept in some respects. But there is also the option of being more robust than PAS 2038, but that would mean others taking on board additional responsibility. Now, I could talk a lot about that, but I'm also going, for the moment, I'm going to be focusing on Clause 11, because in Clause 11, it brings up for the first time in any of these PAS documents the need for an inspection and test plan. I think that should be read as inspection and test plans. But this is only detailed as a requirement for those buildings of over 1,000 square meters. What is an inspection and test plan? Well, let's look at a retrofit measure. So if we're looking at installing internal wall insulation on a traditional building, very often that traditional building, unless it has special protection, would have probably been treated in a modern way, which means it would have had a modern plaster applied at some time in its past. And that needs to be all removed, and we need to go through the process. The processes you're seeing in front of you, this is the process, and these are the implementation stages of installing internal wall insulation. And we must ensure that all of these activities and all of these stages are undertaken properly. But how? How? Well, we can do that by stating within the specification that there is a requirement for the contractor to prepare an inspection and test plan for that particular activity. And within that inspection and test plan, the elements of work will be broken down into implementation activities, which will then be detailed into an inspection and test plan. This is an inspection and test plan I prepared some time ago for a contractor doing this work. It could be done in other ways. In fact, PAS 2038 doesn't state exactly what what an inspection and test plan looks like, but it could look like this. If you want to have a more detailed description of an inspection test plan, you can read an article on Design and Buildings Wiki, but this is a very basic one. It's a pro forma, and on this pro forma, you see all the different activities, which is the implementation stages. It got some notes to explain things to you. It's got the evidence that should be provided. And this is filled in on an everyday basis by the site manager in charge of the construction project or somebody designated by him or her. It's not all filled in every day, but it is filled in every day. Relevant parts are filled in every day. And then this form is then scanned or photographed and sent to the person monitoring quality on behalf of the client, together with any evidence. And the evidence is very often dated photographs. Anyway, that gives you some idea of what an inspection and test plan could look like if you're not familiar with it already. And then we got testing, commissioning, and handover. And then finally, we have the evaluation. And that sums up the main process for all buildings. Where we have small non-domestic buildings, which are small in terms of construction type, small in terms of size, small in terms of the height of the building, small in terms of domestic-like building services, then you could alternatively cover PAS 2035. But if you're going to be doing that, you need to make sure you're using the most appropriate type of energy modelling, and you must also make sure that the retrofit coordinator is also a qualified non-domestic energy assessor. I'm not going to be talking about PAS 2035 in detail here today, but if you look on YouTube, on the IHBC YouTube channel, you will also see a webinar on PAS 2035 applied to traditional and historic buildings, and you may want to refer to that. Where we've got buildings which are protected and traditional, they're clubbed together, you will see from this that individuals undertaking those activities detailed in the bullet points need to obtain a level 3 award qualification in the retrofit and energy efficiency of traditional and historic buildings. And if you are the designer, you must be conservation accredited or certified in accordance with the requirements of PAS 2038. But I deliver the level 3 award course, and I find lots and lots of architects attending that course to get the qualification, because as we know, many architects don't just do the design, they perform other activities as well. There's also a need for a very detailed significance analysis and heritage impact assessments, and they must be undertaken strictly in accordance with BS 7913. So I'm not going to talk about the detail of that. That is for another day. But if everybody's interested in undertaking the 2-day course that achieves the level 3 award qualification, then you can sign up to the Environment Study Centre, and I will take you through what is involved in the development of significance analyses in accordance with BS 7913, and I'll also take you through very detailed heritage impact assessments as applied to retrofit projects in accordance with BS 7913 again. That course is broken down into these activities. It's based upon an e-learning platform that's kept regularly up to date, and you've got links to all other different, it's almost like an encyclopedia, if you like, of retrofitting traditional and protected buildings. So if you're interested in that, you know what to do. Anyway, let's go back to what PAS 2038 says. I've showed you this already. So I've showed you there are some additional requirements in complying with PAS 2038 if we have a protected or traditional building. And those requirements are based upon needing to comply with elements of BN 16883, that European standard for retrofitting historic buildings, and also BS 7913. Now, when I deliver training sessions in person or online training sessions, which are not webinars, but we have a small number of people, I find an extremely low number of people have any familiarity with this particular document. And I've used it on a few projects, and in fact, I've used it on my latest project. So I use this. So what I'm saying is, I know what it's like to use this particular document. So I'm just going to summarize its use, because if you are going to be working to PAS 2038, you are going to have to be familiar with this document and apply this document to a traditional or protected building if you want to comply with PAS 2038. Anyway, I'm not going to read all the words on the screen, but what you can see in front of you is an overall process, is an overall retrofit process that's detailed in BSEN 16883. It's a very basic process, but it's a very logical process. And generally, when we're at the stage of initiating the planning process, generally, we need to explain why the work is necessary. That's a key point in that. At the next stage of this process, that's detailed in section 7.1 of BSEN 16883, we got the building survey and assessment. And I just want to point out the beginning of that particular section where it says provides the necessary information about the building in order to make an informed decision on any energy performance improvement measures. Okay, that is logical, isn't it? That's exactly what we would have to do anyway if we got a protected building that we need to get consent for. And then the next stage, as described in section 8 of this particular process, and section 8 of the European standard, we need to specify the objectives. And you see what the objectives are. They're detailed in section 8. And it says where the areas where targets should be specified are. And when you're looking at all those particular bullet points there, they are detailed also in table 1 of this European standard, which I'll show you all in a moment. So then we're at the next stage where we're going to be specifying objectives. And as we say in section 8, some very important points to make when we're specifying the objectives. We say that any energy performance improvement measures shall be integrated in a long-term management strategy for the whole building. And that is totally common sense, I would suggest. It also says that the process towards improved energy performance can be initiated by factors that are not directly related to energy performance. For example, a general need for maintenance and repair. Now that expresses the holistic nature of this particular document, which should be applauded. And it also says that projects driven only by financial subsidies or technical products shall be examined carefully for their consequences. And what we're basically saying is that we should be undertaking projects properly, not purely based upon a financial incentive or designed around product and manufacturers' recommendations. That, in a nutshell, is what it's saying. Now, this is table 1 that has been referred to. And table 1, I think table 1 gives this standard the most authoritative status, because what you've got to do when you're assessing your building or part of your building, you've got to assess it against every single word that appears in table 1. Anyway, let's go back to the next stage. The next stage is deciding if improvement of energy performance is needed, as detailed in section 9 of the European standard, and I want to highlight this. In this stage of the process, a decision should be made whether the building needs improvement of energy performance or not. It could be a building that's already been improved. Could be. It's possible. And then we get to this other stage, 10.1, which is assessment and selection for energy efficiency or energy refurbishment, as they call it. And this expresses, as detailed in section 10.1 of the European standard, a step-by-step approach. And these are the steps we take: compiling a long list of measures, excluding inappropriate measures, assessment of remaining measures, selection of packages of measures, and assessment of packages in relation to targets. So what did section 10.2 say about all of that? 10.2 is titled Assessment Criterion Scale. It says this should be a systematic assessment. So a systematic assessment should be made that will follow the content and detail of what we see in Table 1. That's what this European standard is saying to us. So again, let's look at what Table 1 says. Let's remind us of what Table 1 comprises. It comprises all these different activities that you need to assess the building and parts of the building against. Now, that's a very brief review or overview of PAS 2038. But let's think about whether this actually achieves the objectives. Will it improve the functionality and durability of buildings? Well, I've only given you a glimpse of PAS 2038, but I would say there's a good chance that it does. And I tell you why. And that is because it has a focus on what is detailed within BSI 16883. And that's one of the reasons why I'm quite confident that it does. Improving the comfort and well-being of occupants, improving energy efficiency, reducing the environmental impact, protecting and enhancing our architectural heritage, minimizing the performance gap, and avoiding unintended consequences. To be honest, I'm more confident that PAS 2038 can do this compared to PAS 2035. And there's a number of reasons for that. I think the main reason is that levels of competency required in PAS 2038 is much higher than PAS 2035. Within PAS 2035, there is only one role that requires a professional qualification. And when I say a professional qualification, I mean a qualification that comprises a professional membership of a professional institution. And in PAS 2035, that is only the retrofit designer role in respect of some projects, maybe most projects, but some projects. Whereas in PAS 2038, there's a need for professional qualifications scattered through the whole document. Okay, so we got a much better chance of achieving these objectives because we are having a more professional team approach compared to what we have in PAS 2035. So I would say there is a good chance. And one of the reasons for that is, of course, the fact we are referring to two very robust standards in PAS 2030, in BS 7913 and BSEN 16883. So this is the overall process, and it's not just PAS 2038 document we're referring to, we're also referring to these other documents as well. Anyway, if you want to have more detailed knowledge of this, I have been delivering lots and lots of in-house courses to clients around the UK, ranging from very large consultancy practices to local authorities, museum estates departments, and other organisations as well. And I do deliver it seldom as a public course. If anybody's interested in knowing more about a PAS 2038 generally, then you know what to do. Anyway, thank you very much for listening, everybody. And now I'm happy to take questions.